Hey, how's it going, guys? So here we are back again at the Python BACnet Stacks Playground. I have some kind of exciting things to show you with this Vibe Code App 12, which is basically it's the AWS fault detection application, scraping data from the building to AWS IoT Core, and then I have some AI workflows associated with this too. Also, I'm building in unit testing as well to this Vibe Code App 12. I'm almost tempted to put it on its own repo in time because I think it's kind of neat. So basically, let's just get down to it. I think I've explained enough that this is basically turning into model context to do basic BACnet applications for read-write, priority array, read multiple, as well as doing discovery processes, point discovery processes, polling. So right now we're kind of playing around with vibe coding a building automation system and then seeing if agentic AI can build a building automation system with a skills specification. And then I have this set up now. So basically, AI is completely managing this fault detection cloud full pipeline from the building to the cloud, deploying BACnet drivers on Raspberry Pis, and then also as soon as the human in the loop, which is me, authenticates the AI with AWS, it can even maintain all of this web app code, which I'll demonstrate here in a second. But yeah, so this is Vibe Code App 12. I might stick this on its own repo at some point in time, but it's really cool because I've basically just instructed AI to create its own drivers based off of earlier things we did here. So basically in IoT, we just scrape data from the building and pass it off to the cloud somehow. So we've done enough work in this series to basically point AI, install these BACnet drivers on these Linux IoT edge devices, and let's start pushing data to the cloud. It's maintaining its own scripts and everything. So another thing that I'm doing too, I just thought of, I'm also telling if AI is maintaining all of its own code, we should be doing packet captures in Wireshark. So I'm validating on it's hard to know what it's doing, but I think if AI gets really autonomous in this part, we might just have to resort back to prompting the AI deploy on these edge devices, scrape all these devices, and then a way to validate that it's doing something. It's not only on the cloud on some dashboard, but also taking a brief Wireshark packet capture, and then validating just doing read requests on some certain intervals that you need. I just thought about that. So let me show you a few things. So this little schematic is getting a little complicated now. So here, this is me. We're on this Windows computer, which I demoed a whole bunch, recording this YouTube video. I have Cursor AI IDE logged into via SSH to this. It's just a Linux server. See the YouTube short if you want to see this test bench, which is not very impressive. It's just a windowsill at the moment. So hopefully someday it'll be actually a proper test bench, but it's just a windowsill. So this is just an old Windows desktop computer converted into Linux and Ubuntu. So this is what I'm hosting Ansible with, which is an IT automation tool, which I think people use it. So IT people use this to maintain servers at scale. It could be web apps, it could be data centers. I think people also use it in IoT applications. This could be IoT edge devices. So basically I can bootstrap these. I'm using one Raspberry Pi, and then in the future, which I'm hoping to do very soon, is also use Ansible to push code through Tailscale VPN through the internet to some Linux Ubuntu machine on a real HVAC system, which is actually kind of mimics this very well. I know someone that said, yeah, go ahead, you can test this out in my building. I'm not getting paid or anything like that. It's just a way to validate that the code works. But just to confirm that that this will work on a live HVAC system too. I feel very confident just in what we're replicating here on the test bench, but it does actually look a lot like this. It's a roof-mounted air handling unit for a medium-sized office with a couple VAV boxes. Okay, so just getting back to this, I now have a BACnet router on the windowsill test bench, and then a JCI FEC board with a few more sensors on it. So like if we open up on the Windows computer here, let's do like a BACnet discover. These two devices should pop up, the BACnet router and the FEC. This is BACnet MSTP, so this is the GPIO sensor right here. So that's reading, let's see what it's reading in degrees Fahrenheit. We made all the BACnet code to get this data. So it's reading 70 degrees Fahrenheit. And then this is, it's probably hard to see here, but this is network 2000 MAC address 7. So this is the JCI FEC. So this is network 2000 MSTP RS45 here to an old JCI board that's retired. So let's see what it's reading. Ooh, 69. So not too far off from the GPIO, the one-wired digital temp sensor. I trust this JCI sensor actuator bus sensor a little bit more than GPIO sensor, but it's nice to know that they're close to each other. So also the duct temp sensor, 51 degrees coming out of the air, which I can validate. It does feel quite cold in my crappy office HVAC. Okay, so just to reiterate here, like we're using Ansible, and I'm still playing around with the Codex AI CLI with the custom agentic AI code, which is not very complicated. It's just literally a Python input function that calls the Codex CLI, and it's bootstrapping Ansible to push code to here, revise it as necessary. I can take a packet capture on here, and then I can also use Codex CLI to go across the internet and then re-bootstrap my web app, which is running on AWS IoT Core. So this is a Lambda function. And then eventually, coming soon, we're going to use AI to push Python scripts to, this will be an Ubuntu virtual machine that the IT department is hosting. So like the IT department at this organization is giving me a virtual machine that is on the same subnet as the building automation system, which is just a teeny little train system in some office. So I'll be able to run Tailscale on here and then push the same web app code that's running on here to this Ubuntu virtual machine, except that we won't be doing any GPIO temperature sensor stuff. We'll be talking live building automation system data and publishing that to AWS, and then running fault detection and doing some data modeling on AWS IoT Core too as well. So hopefully this makes sense. It's getting a little bit more complex, but so far it's still free. There has been some people saying this is AWS platform, that AWS is really hard to maintain at scale, and it's not cost effective. on using the tech giant IoT platforms. I guess I haven't ran across that yet. So if it is, I just haven't faced it. So I'm sure it is. This is also the little I am feature. So like Codex. So like I authenticate Codex running here. Codex is also authenticated with OpenAI, but then it's also authenticated through AWS IoT Core through this I am feature. So I'll demonstrate this in a second. So basically, I give Codex the full ability to rewrite the web app code, do anything it wants, but it's all like one-shot prompting. Like I shut it down, so I'm not letting it. It does have the feature like where you could mimic OpenClaw or Hermes it can create its own cron services. So if you wanted it to wake up every hour, every couple hours, whatever, you can still do that. It has the ability to do that. I just have to watch my Codex usage. So with the OpenAI subscription, you can use some Codex. So this is basically what I'm kind of running here. I can also do all of this stuff just through Cursor, through the AI IDE Cursor, and I think it's really cool. Like you could totally do this through Claude, whatever is your preference. I've just had such good luck with Cursor. I have such a hard time wanting to shift it to something different. So like this is my Cursor stuff. I have to dumb this down to $20 a month plan because $60 a month is kind of ridiculous. But I would probably keep it at $60 a month if I was using it a lot. But I can totally just use an AI IDE to do all of this. Because like I don't think I really need at the moment any ability like OpenClaw to like be fully autonomous, to wake up in the middle of the night and start be doing things. I just I feel like I just need something to do stuff in the moment. Like I get to my office and be like, I need to rebootstrap this web app. I want to change this code. Just work for me today, right now. I iterate until complete. And then I go home at the end of the day, shut my computer down, and I also shut the AI agents down too. Like at the moment, I just don't need it to run all night long. Maybe someday if this was at scale, yeah, sure. But I'm not quite to that point yet. So this is what I'm doing on AWS IoT Core. So like for testing this, I'm only collecting so the Dynamo database I'm only have it set up to collect 7 days worth of data. It's not much data, so it's just for testing purposes. But to keep this cheap and easy and low cost, like I'm gonna go bare minimum on what I need to collect from the HVAC data, or from the HVAC from the building. Like you could collect every building automation point as possible. I am going to run an auto discover script on the BAS, but then I'm going to also use Cursor to I'll be auto discovering the BAS, which I could probably do on another YouTube video, but then I'm also using Cursor to trim down these files. It's saved in a CSV file for only collecting bare minimum of what we need for fault detection purposes. So for example, if there was 20 VAV boxes and each VAV box could contain 70 BACnet points, but we probably only need 4 or 5. That's only 10% of the points in the building automation system are useful for fault detection purposes. I'm only going to scrape bare minimum and probably at 1 minute polling. We could even do 5-minute polling too. So it's I'm not going to auto scan the BAS and collect every point in the building automation system and be routing mass amounts of data across the internet. It's just going to be bare bones. And what's really kind of cool on the edge environment too is like I can just chat with Cursor or Codex to, like, it knows, like, through, I don't need any data modeling on the edge. I'm only doing that here. For external brick time series references, is like it will know based on the point name that it's a zone temp sensor, that it's a duct temp sensor, that it's a mixing air damper output. It's pretty good. Like, it's I can vouch, any good controls person that has been around the industry. Maybe you've worked in a couple different shops, a couple different product lines. You can kind of glance at a CSV file of points for all these devices, and you can be like, this is some kind of temp sensor. This is something not. You have a pretty good sense at of what kind of data it is. Anyone in retro commissioning too. So I think the AI is just as good as I am. So hopefully that makes sense. We're going to be just throttling manually by bare minimum point polling and collection from the building, and then bringing it to AWS IoT Core. And then I'm just going to be exploring if I can get away with 2 months worth of data. That's all I'm going to keep on the cloud, just to keep it free and cheap. So people have say, like, it's not good at scale. I'm sure it's not good at scale. It's probably really hard to maintain this at scale. But I'm gonna explore, what it is to keep it cheap. And I think, like, this could be useful for, let's say there's an energy manager. So for one thing, I want to demo this in a second. This Vibe Codec 12 interface, that's a web agent on AWS IoT Core. So let's say you're, like, what I imagine, like, this would be you're a school district. You're an energy manager for a school district, and you have a portfolio of schools that you manage for your district, or a hospital. So maybe 20, 30 buildings at max. Maybe you're maybe you work for a higher education university, and you have another campus of schools, 20 to 30 buildings at max. It's just a single login meant for one person to log into this AWS IoT and run your reports, download plots from Plotly. Like, it's not an outward-facing client application where it's more like specifically built for the fault detection engineer that is gathering the useful data and reports for the client, and then they'll ship maybe a Word document or PDF to the client, or perform like a PowerPoint or something. Like, it's at least that's the way that I'm going. But it is completely customizable. So, like, in this web app 12, there's just this model context. Like, you could make it into anything you want it to be. You just chat with the AI, and it has full ability to modify the code in here. So you could make it what you want it to be. So that's kind of where I'm going with this. Hopefully that makes sense. So, like, some people could be building a framework that is meant to be like Grafana, like you log into it like the client would, something your end client use. But for me, this is like, I imagine this to be something that the master systems integrator or the monitoring based commissioning agent or engineering firm owns directly, and they manage it, and then it's not something that their client logs into at all. It's just a tool for them to collect data. Really curious on your thoughts. Just DM me post a comment on Discord or on here. So hopefully that makes sense. So, like, when I start deploying in this other building, I think there's 2 BACnet trunks. in this other building, and then a large rooftop unit on its own BACnet IP controller, and I think there's a boiler system too. So it's just a small to medium-sized office, and we can start collecting fault detection data and then run some more sophisticated faults. Okay, so I need to shut up about that, and then I'm just going to kill this as well. Okay, so this is the fault detection. This is a web app code created by AI. Okay, so you just have a dashboard showing a sensor here. Let's test out this drop down. 48 hours, I guess. See if this is working. That does not seem to be working. So like this is, there's a way that you can, so like what I've been testing out here is this AI-assisted data modeling. So I told Codex CLI to create all of this. There's an API on the end. Maybe this is the chart that I want to show you guys. So like we're collecting on the test bench. So let's just see all the stats on my test bench. This is so I told AI to apply a brick class. These are technically all of the same. Ooh, this is coming in through degree C. Okay, so this is all of the zone temp sensors in my office. Wow, there's one that's actually reading a lot lower. Oh, that is the JCI. That is the JCI sensor actuator bus. So just reference the earlier video. So this is like the data modeling AI-assisted. Codex did all of the data modeling for this, and then if we just look at the duct temp, which is just a duct probe stuck into the grill of the air conditioning vent in my office. Yeah, it discharges 50 degrees. It's really cold. Pretty cool. So like what I wanted to show you is that this is just another little dashboard about the edge device. Okay, so like AI can do all of the Python code here. It has an API to do all this, and like what I'm trying to build is that we can have one Python script that will be applied to any different brick class. So like we'll have Python code that can be applied to a zone air temperature sensor, outside air humidity, discharge air temperature. So this is coming. It's not really ready yet, but we'll have the same test rule button. So that's coming. Write the data to the database. And then this is also like Codex did all of the AI assisted data modeling here. So it's this is really cool. Like I didn't have to do any of this. Like Codex pushed the scripts to the edge to start polling for BACnet, publishing MQTT data. It validated that AWS IoT Core was able to get the data onto the cloud, and then it also created this data model. There's still also a way to export the data model via JSON, which I still need to build this out a little bit better. But and then I also want to just show you that you can see the data model here too. So there'll be a fault rule connection, and then there's also should be external time series references this would be through the DynamoDB on AWS. So it's coming, it's getting a little bit better, but this is basically supposed to represent brick times the brick data model and also in turtle format. So hope you guys are liking this. I'll be able to keep on building this out and then show you guys a little bit more into the future, like as we kind of get better and better with this. So it's coming. It's and I think like the neat thing about this too is that this vibe code app 12, it's just something very generic that like anyone could just, it's supposed to just be model context that anyone can modify the code. They can change this into engineering firm X, Y, and Z, you know, like that's what it's meant to be. It's just something really generic. And then they'll also just be what I'm still working on, besides, you know, combing over a few bugs, you know, that kind of thing, is building out, like once we get this into a better, like into the full-blown, let's see, where am I? Once we get this into the full-blown building, that's a real building, like we can do, there's also a rules expression here too. So I'm going to find out where that went. I did a little bit of refactoring here, so I have to just find the expression rules cookbook. So, you know, there's also PDF documentation here. Let's just see where it's at. This is a little bit how the edge device is working. Okay, so like as soon as we get into you know, just something a little bit more stable, what I want to do is start running more sophisticated fault rules. So it's coming. Thanks for watching, guys. We'll I think the next time I'll talk to you, I'll have this up on, you know, fix some of these little bugs, and I'll have this up and going on the real deal, on the real building. It's coming. So thank you.